Section 1.6a is about the commutative and the associative property. These two properties are things that you've probably been doing all along, you just didn't know what they were called. So we're going to start by defining the commutative property. It says the order in which you add or multiply numbers does not change their sum or product. Quite simply, that just means if I add 2 plus 3, that's the same as adding 3 plus 2. That's all it's saying. I can do 5 plus 4, or I can do 4 plus 5, and I'm going to get a 9 either way. That's the commutative property. The important part here is the commutative property is all about the order in which you add numbers, or you could multiply. So there is such a thing as the commutative property for addition, and we also sometimes say the commutative property for multiplication. So it also works there. If I were to go 7 times 3, it's the same as 3 times 7. Now the way that I like to remember the commutative property is commutative has the word commute in it, and commute means to travel. Your parents commute to work, or you might commute to school, you might travel there. And so the order, the numbers travel into a different order, but it doesn't matter, they're still equal. And that's how I remember the commutative property. Our next property is the associative property. And it says the way you group numbers when adding or multiplying does not change their sum or product. So if I'm going to add some numbers and I choose to group these first two numbers, thereby telling PEMDAS that I want to multiply, or excuse me, I want to add 2 plus 3 first, that is the same answer as if I group the other two numbers. Either way, you're going to get 5 plus 4 is 9, or 7 plus 2 is 9. It's the same thing. It works for multiplication as well as addition. I can do it that way, or I can do it this way. I'll get the same answer whether I do 2 times 5 is 10, times 3 is 30, or 5 times 3 is 15, times 2 is 30. So the associative property is all about the groups. The way that I remember this property is the word associative has the word associate in it. It's like if you associate with someone, if you hang out with someone. So in my mind, the 2 and the 3 are hanging out here, but the 3 gets mad at the 2, so the 3 goes and hangs out with the 4. But that doesn't change the fact that these two expressions are equal. I know, it's stupid, but it's how I remember them. Here are some examples to show us how the commutative and the associative property can be useful. If I look here, I'm multiplying 4 numbers. And I could multiply these from left to right, and it would be easy to do. But I want to show you some way that you could rewrite it to make it a little bit easier. If you notice here, I could multiply this 2 times this 5 and get a 10, and we all know that multiplying by 10 is really simple. So what I'm going to do is I'm going to rewrite this, and I'm going to put the 2 next to the 5. Now the reason I can do that is because of the commutative property. The commutative property says I can do 2 times 3 as well as 3 times 2, and it won't matter. Now I'm going to use the associative property to group them this way. I'm going to do 8 times 3, which is 24, and 24 times 10, which is 240. One of the things that these properties allow you to do is switch numbers around and group them in such a way that you might be able to do them in your head easier, because it's a lot easier to multiply 2 times 5 than it is to do 3 times 5 and 8 times 2. And so I can flip those around using my properties. Same idea here. I'm going to use this picture that you see in your book to find the distance from the 5 points location and travel to, I believe this one here, Lakewood and Fort McPherson. So what I want to do is I want to add those 4 numbers up to find the total distance. 1, 2, 3, 4. So I'm going to add those. Now, just looking at it a little bit, the commutative property says because I'm adding here, I can move these around any way that I want. So one thing that I'm going to do is I'm going to move the 1.1 closer to the 0.4. Why? Because 1.1 and 0.4, when I put those together, gives me a nice 1.5. Then when I combine these, I get a 3.0, and 3.0 plus 1.5 is 4.5. So one of the things to point out is that the commutative property and the associative property only work if you're doing all addition or all multiplication. If you start mixing them and matching them, or you start doing division and subtraction, it doesn't quite work. Here I'm given some problems that I have to evaluate, and again we're going to use the commutative and the associative property to make our job easier. As I look at these three numbers, I know that a number that ends in a 6 and a 4, that's going to create a nice whole number with a 0. So I'm going to rewrite this by using the commutative property and flipping 26 and 18. And then I'm going to associate these two so that I add them first. So 26 and 14 is 40, and then 40 plus 18 is 58. Again, you can solve this without changing the order. I'm just showing you how sometimes changing the order can help you do them, especially in your head. They can save you some time. Over here, are any of these numbers easier if I multiply them together? Well, in my mind, 5 times 4 is a lot easier than the other ones, because 5 times 4 makes a 20. And then 20 times 18. Now 2 times 18 is 36, and then we got a 0, so 360. And I was able to do that because I flipped them with commutative property and then associated them with the associative property. Over here, 2 halves make a whole, so as far as I'm concerned, it's a lot easier to think about this by adding the two that have a half in common. So 3.5 and 2.5 is going to be 6, and then 6 plus 4 is 10. Again, commutative property to change the order and then to associate them. Last one here, I like to change mixed fractions into improper fractions. So that's 36, 9 times 4 is 36, plus 3 is 39 over 4, and then I like to turn the 16 into 16 over 1. Now I'm going to associate these last two because I can use cross-canceling. 4 goes into 4 once and into 16 4 times. So I end up with 5 over 6 times, now I'm going to change this to 39 over 1 times 4 over 1. And the reason I do that is because now I want to cancel the 6 and the 39. 3 goes into 6 twice and into 39 13 times. Now, because I'm able to flip all these, I'm not going to flip them all again, but I want you to notice something. 2 can go into 4 twice. And that's legal. It's legal for you to cancel something way over here to way over here, because we could just flip these two and move them closer if we wanted. So 5 times 2 is 10, plus times 13 is 130. So the commutative property and the associative property make it easier for us to evaluate expressions that use multiplication and addition.